density. So it's going to density. Density is how much mass an object has um, how per volume. So this example, you have water, which is 100 milliliters of water, and you have 100 grams. It weighs 100 grams, and you have only 10 milliliters of water, which is less. But this weighs, so this is 10 milligram, but this weighs 100 grams. So they both weigh the same thing, but because mercury is much heavier than water. So what's the density? What's the density of water be equal to? Density is mass over volume. Density is the mass of an object per volume. So density of water would be mass 100 grams divided by volume, which is 1000 milliliters. So this and this and this would cancel, and you get 1 gram per 10 milliliters. So that's the volume of water. For every 10 milliliters, it weighs 1 gram. Mass of our volume, or 0.01 grams per milliliter. In this case, if we convert this, you get 0.1 divided by 10, or 0.1 grams per milliliter. So every milliliter per milliliter is only 0.1 grams per milliliter. Now mercury, the density of mercury's mass over volume, which is equal to density of the mass of mercury is also 100 grams divided by volume of 10 milliliters. So this and this would cancel. So you get 10 grams for every milliliter. For every milliliter, which is equal to 1, which is equal to 10 grams per milliliter. 1 divided by 10 is 10 grams per milliliter. It means that mercury is more dense, because mercury, for every milliliter, mercury weighs 10 grams, right? For every 0.1 gram, for every liter, mercury weighs 0.1 gram. For every milliliter, here, for every milliliter, mercury weighs 10 grams. Here, for every milliliter, mercury weighs 0.1 gram per milliliter. So from this you can tell that mercury is much more dense. So it gives an idea of how much more dense. So it doesn't matter how much substance is. A substance can be less, but it can be more dense. So here you have water, which is more water, same weight. You could even increase the weight, it won't make a difference. Here you have mercury, which is less amount, but you same mass. So now because of that, mercury is more dense. It has more weight on it. There are more weight packed into it, or more atoms packed into it per milliliter in this case. Right. So let's say you have a ring, and the ring is made of gold, right? It's a gold ring. The ring is made of gold. And you want to know whether the ring is pure gold. You can't tell by looking at it. You can look at it. You could even the top could be covered with gold, and the inside, even a little bit, could be not gold. We want to be able to tell whether or not the substance is pure gold or just mixed with something else. So first thing we do is we weigh it. The first thing we can do, we can weigh it. So we weigh the ring. So if we weigh the ring, we get 22.5 grams. We take the volume of the cube, put in a cylinder. We take the volume of it. We get the volume to be this amount, and we find the density. Now we know if it's pure gold, we know density. The answer density of gold is 19.3 grams for every cm cube. So this answer is supposed to come up because this only measuring per cm cube for one, not 2.38 cm cubes. Measuring 1 cm cube, how many are? So if we find the mass, if we find the density, which is equal to mass over volume, then we get mass is 22.5 grams divided by volume, which is 2.38 centimeter cube. And then when this and this cancels, you're left with, so when you divide, you get 9.45 37811513. In chemistry, you deal significant figures, so you have 1, 2, 3 significant figures, 1, 2, 3 significant figures. When you divide, you take the least amount of significant figures, which is 1, 2, 3. 1, 2, 3, so 1, 2, 3. So the answer will be 9.45 grams per cm cube. So the density of the ring is only 9.45 grams. The density should be 19.3. So that means that because it's much lighter as well, because the density is not the same as the density of gold, that means that it's not real gold, it's fake gold. Fake gold. That's how we use density, or one of the reasons. So when you talk about measuring the correct number of digits, I mean that the more digits you have, the more accurate the number is. For example, the number, if you weigh something like, let's say you have something like this, you weigh something, in this case, a box, and the scale reads 5 kilograms, and you have another box, another type of scale, and the scale reads 5.2 kilograms. You have another scale, and the scale is 5.2934. So it'd be 4, 3, 4, 5, 7, 8, 7. The one that's more accurate would be this number 3. This one would be more accurate because there's more decimal places here. So that's what I mean by accuracy. If you have a funnel like this, and you have to weigh something, this is 5, 10, 15, 20 milliliters, and you have water, and you put the water in there, and the water comes up to here, right? See this measurement here is 10, 11, 12, this is 12. So the measurement seems to be not on 12 but a little bit off. This is 11. So the measurement seems to be between 12 liters and 12.1 milliliters. Right? 12.1 milliliters. So in this case, what we do is you draw a line here, and then where it says 12.1, and then you divide that by 10, because it's 5 by 5. So take another measurement between that. I see the closest measurement would be between that would be 12 point, maybe 12.1. Right? So a more accurate measurement would be 12.11 because it's 12.1 and then you break the 1 up and get 12.11. Another easy example is like this. So you have a scale like this, you have 4, 3, 5. And the measurement is between 4 and 5. So your measurement is like 4.5. So what you do is, because the measurement is 4.5, you break off the distance between 4 and 5 into 10 pieces. So from here to here might be 1, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So the answer would be 4.57. So what you do is you break this up. You measure from the bottom 4.5, then you break from 4.5. Say from here supposed to break to 10, and then you take 10 measurements of it. So this one, you have 4.5, you have 4 here, 4.5, you have 5 here. So what you do is, the measurements is between 4 and 5, so it's 4.5. Now from 4.5 and 4, you break it up into 10. And then you take that measurement, so you get 4.57. So that's how you get a more accurate measurement.